So if yeah, it will pop up. The idea, the interface of the method is, I don't know if it is standard or not for other types of software that you use. Instead of buttons like in calculator, and instead of drag and drop mouse click, it is a command line. It is the simplest possible command line in any other, compared to any other instances where it is used, but it is like a chat line, where you just talk to the CPU through some interface. And is the font large enough for everyone to see? I can probably enlarge it, but if you're happy, then please give me a sign if you prefer a larger font.
I mean, if you could just maybe like extend the window.
Oh, expand just to for larger.
Yeah. There we go.
Okay.
If that works for you.
Yeah, it works for me perfectly. So you can use it as a calculator, right? And this is probably natural things to try. Then one can use it before you go to matrices and functions. And probably do not worry, we will need to go through this process once again next week when everyone will have an access. So it is more, we'll do today's meeting very brief and entertaining, so that you do not spend much time on math. If you can install it on your laptop, figure out how to do it, it will be a plus, but you will be provided with working equipment. If you do not know where to start, you can type help or demo, and it will show something. But I do not like it. I try to. As kids, when they play, they break toys and see how are they constructed. So we probably should do this way. So two things we will need. Well, of course more than two. But before we go to the matrices, we may look on regular functions and graphs. So what is a function? It's not for the record of the grade. You all know it. Just tell something.
An expression of variables?
Yes. You answer like a professional mathematician. But if we are simple guys who have experimental data and plot the functions in Excel, like some dependencies, we can think of a function as a set of two sets of data which are in correspondence. One set of numbers it is x-axis, and then another set of data is y-axis, and then they correspond, right? On one hand. On another, it is, as you've told, it is a set of functions, a set of variables in some arrangement, like three-story building, with some. The argument, the x-axis, needs to be defined by grid points. So if you type the word x, it will tell something bad to us, because like we didn't define what it is. But we want x to be like points on the x-axis from 0 to 10, right? So we can type x is from 0 to 10. No, it doesn't work. Can we do 0 to 10? So 0 colon 10. Then it sets up a set of grid points. But now they are spaced very loosely. If you want mathematical functions, we want to have them narrower. So we may set up an increment, like 0.1. So initial, final, and increment. And then it is too much to watch, but they are densely spaced. Good? So simplest function is linear when y is equal to x, right? But if you type something, let me. I want to show two windows at once. So if we replace, like, what is the simplest function you can imagine, like x squared? It will not work. So you use this argument, you put the mathematical function that you want, and then you plot and you see the function. So it is basically like graphically enabled calculator at least. Okay? And so I'm showing something simple, but we can always, all functions that we process in the class and we try to do to process them by equations, we can replace it by this numerical treatment. What else? Complex numbers. What should I type to check if this environment allows for complex numbers?
Square root -1.
Huh?
Square root -1.
Yes. That's. Oh, what do I have to do? Even more entertaining. Otherwise, I'll sit in the thing myself.
I mean, gotta show off my skills at some point, right?
Try to do it.
Enter.
Yeah. So there is a real and imaginary part. And we can try our favorite. We can actually define, let's say, this number, and then there is an exponential function, and if you put 0, it is 1 as expected. Exponential of 1 is 2 point something. But now we can put here imaginary unit, and see it allows to take imaginary exponentials, which is reasonable for our effort in processing waves. So brief overview of functions and graphs is that. Now let's do matrices. No, vectors. They are simpler. So which types of vectors do you know? Who was presenting it in class?
Here's it right here.
So which types of vectors do you mark? Do you remember? It's not a trap question. It is like, huh? Yes. So if the software is smart enough, it should give us an opportunity to do it. Row vectors and column vectors. Bless you. So why don't we write something like simplest vector is with 2 elements, 2-dimensional, right? And if we type it, if you do not close the bracket, it allows to continue the column. You see it? Right? So it's ways to define row vector and column vector. Sometimes it is normal to forget things. So one can ask which variables we were playing with. So that's remember. Now, what should we do if we do have row vector and column vector? Natural thing, or maybe unnatural. What can you do with two vectors?
Multiply them.
Yes, in which ways? You can do cross product if it is three-dimensional, and you can always do scalar product, row by column, and you can do diagonal product, column by row, which we will do later. So row by column. Which one is row? A. And column is B. Right? What should we get? What will be the answer? So 1 vector 1, 2 times vector 3, 4. 1 times 3 plus 2 times 4. Would you agree? I can make errors, so you don't need to agree immediately. Okay. Yes! See, so it's multiplying matrices, but now we did a test for this silly computer with core software on something that we can control with our brain. But for software, it doesn't matter like length of vector in 2 dimensions or 100 dimensions, which is a little boring for us. What else? Matrices. So you can define matrix, and then you can multiply matrix by row or column. What is more natural? Column. And this was B. And it does generate the column vector. Or if you really want to multiply matrix by the row vector, you should do it from opposite side. And then you get another row vector. Make sense? What else? Well, next time we should select some simpler metrics, but the command eig is for eigenvalues, and this notation, when you set up three matrices and equal to eig, it does generate the eigenvalues and eigenvectors which are recorded as a set, vector 1, vector 2. So I can happily continue, but I'm not sure if you remember anything without practicing. So what is your? You better ask questions and contribute to leading the discussion, because we shouldn't overwork before we get an access. I see potential for asking questions on your side, but I cannot guess what you're going to ask. Yes?
I guess I have a question. So when we have, like these homework assignments and everything we have here, we're going to have to use operators, correct?
Yes.
Do we have to define those operators ourselves in the system, or are they pre-existing?
You need to define.
You need to define them yourself.
And not.
If my question makes sense.
It does make sense. Okay. It does make sense. Well, I promised a shortcut, and I do not cancel my work, but it doesn't mean that every single assignment can be done in numerical form. There will be some minimal amount of derivations that we can avoid, but substantial number of work can be done in MATLAB so that we do not put too much pressure on our math skills. That's the idea. So, what would you want? What is your wish list for helper software? Derivatives, integrations.
Can it do that?
Numerically, yes. So, let's return to our sign. So if we do diff, so the derivative of sine is cosine, but one should be careful. It shows different y-axis because it doesn't automatically include a step of this infinitesimal size. So you may want to include it. What this diff command makes, it just compares two neighboring sites of this function, subtract them, and give this back to us. But with precision up to a constant, it is a derivative. What else?
So if you had a function of multiple variables, how would you specify which variable you're taking the derivative with respect to?
There is a way to. I will not answer your question directly, but I will show a way to think about it. Let me open it too. So the semicolon means running all values of a given degree of freedom, given variable. Like if you select first index equals 1 and second index running all possible values. So we select first row, and for the column it runs. So we can parse one-dimensional dependence out of multi-dimensional dependence. Make sense?
Yeah.
Okay. And then you can store it in a different variable and then take a derivative. I'm not showing, although I probably should. There is a lot of tools that allow to make multi-dimensional images, time-resolved movies, and even play sounds. Like sometimes you can convert the function into a sound and listen how it sounds. Do some chirping. It's just too much new information that I do not think it will be helpful if you just listen as in theater, because it is more main idea that it should be practical skills. But you have more questions or homework for me. Well, I have a pretty clear idea what to do and how to prepare next web meeting, but if you have some suggestions.
Can you show the integral as well? You said you could do both.
Yes, I will not show you integrals,
Okay, thanks.
but I
You will not?
I will not. I will not. But there is a so this code in basic this package in its basic implementation doesn't have a tool for analytical calculations, although one can buy this thing. But we do not need it. We need only numerical. And numerical integration makes sense only for definite integrals with specified limits, when you get a number rather than a function. And numerical integration is nothing but summation of the whole function from between specific ranges. So if you have a like array vector or slice of a function in this multi-dimension, you can just type sum, which will be summation of all elements. So if we do this little experiment. So when we defined x from 0 to 10, it does more than one full cycle. And even although we know that if we integrate sine, we get cosine, but then if you make it definite, we may want to do integer number of full cycles if you want to get result of integration 0. If it is less or more than full cycles, then it will be something different. So we defined this blue line for this 1 point halves with something period, and another one only one period. And we can make this pseudo integration by making summation over one complete cycle and more than complete cycle. So sum of will be some number, and if you want to make it comparable, then we need to multiply it by step, by time step or whatever variable step. And if we put another variable which is defined in different limits, it is expected that it will be much closer to 0. So 10 minus to the power minus 4, it is not very far from 0. So it is a very simplified form of numerical integration. If you are involved in this activity, you know that there are advanced integration like Euler and then Runge-Kutta, where then makes spline over several points. It also can be done, but in simplest way, it's just summation. I enjoy your questions. Anything more? So the plan is that we meet. Oh, please.
I guess I have one more. This might be more numerical as well too, maybe something we stray away from. But so you know that example, how we predict the future with like infinitesimally small sets of time. So is there a way to do series on here as well?
Yes.
Okay.
Yes.
Again, is that something that we won't have to?
But there is a way to do numerical series,
Right.
and there is a way to set up numerical propagation of wave function forward in time. It will be main reason, main say, project, main activity where this method skills will be helpful for us. So we will predict future. Yep.
Could you do a simple animation of give that sign a little phase in respect to the process?
Yes.
Is that easy?
It is relatively easy. I just do it when you see the wave and the 3 minutes, where this 3 minutes. But it is, if you give it as a homework, I will show it next time, so that you do not sit and wait. And it is something that all of you will get as a skill by the end of the course, or much earlier. So one of the plans is to convert calculations into animations and upload them to YouTube. Okay, so next time we should have equipment one other way, and you may try to set up equipment on your laptops just to get a little independence from me and university technology, and generally to be able to enjoy the laptop in the middle of the night. Okay, meeting is dismissed. Thanks for coming and investing your time, and see you Friday 11 upstairs.
Good night, sleeping. Good night.